These are the notes for Mrs. Wyatt's geometry class for Friday, December 4th. We're looking today at the triangle inequality theorem. Before I show you the theorem itself, on your Canvas page, I have posted a little exploration of the triangle inequality theorem that looks very much like this picture that I'm showing you right now. If you will go to your Canvas page, just take a few minutes, go to your Canvas page on Friday, December 4th. Take a look at the module that says Triangle Inequality Theorem Exploration. Open that up, click on the link, and the instructions say to open the link and drag C and C prime. Remember, prime is the one with the little hash mark. And connect C and C prime so that you can make several triangles of various shapes and sizes. Pull the vertices around, and what you're looking for is to see if you can find a relationship between the sum of any two of the sides and compare that to the length of the third side. Why don't you pause this video, go to your Canvas page, and try that, see if you can come up with some kind of a conclusion, and then come back. All right, hopefully you've taken a little time to go play with that exploration that I posted for you and figure it out. What we want to complete is the sentence that says the sum of any two side lengths of a triangle is blank, then the third side. The word that you're looking for is greater than, and that is what the triangle inequality theorem states. The sum of any two side lengths of a triangle is greater than the third side length. Doesn't matter which two, doesn't matter what kind of a triangle. I have three inequalities written here that you can look at. The side AB plus the side length from B to C. If you add those two together, it will be longer than that longest side AC. If we take BC and AC, add those together, it should be greater than AB. And if we take AC and AB and add them together, it will be greater than BC. I'm going to show you just a little picture that might help make sure that makes sense to you. If I draw a segment, I'm going to do it right above our picture. And if I put 3 points, let's say this is A, like the A in our triangle, and this is C, like the C in our triangle, and I'm going to put B somewhere in between. And right now, all three of those points are collinear. They fall on the same line. And right now, if I would write the segment addition statement, it would say AB plus BC equals AC. When those points are collinear, you can add those two shorter segments and get the length of the long one. If at any point I would take that segment from A to B and disconnect it at B and raise it up a little bit, and do the same thing for the segment at C, keep them the same length but raise them up, they will no longer match up. They won't make a triangle. For it to actually make a triangle, one of those two lengths would have to be a little bit longer. One or both of them actually would have to be longer, which would mean to make a triangle instead of a straight line, AB plus BC could not equal AC. It would actually have to turn out to be bigger than that. And that's kind of the observation that we can make from the triangle inequality theorem. So again, kind of like yesterday, today is a practice of being observant. What we're going to do is we're going to use that theorem. Let me keep it where you can see it. And we're going to look at three lengths. and make a decision as to whether they could be the sides of a triangle. I'm not going to ask you to draw them. I just want you to make the decision. So what we're going to do to make that decision, we can't just check one to say yes. We have to make sure that if we add all three sets or all three pairs of sides, that they're always going to be longer than the third one. You have to check all three combinations. So we're going to see 4 plus 7 is 11, which is greater than 10. So that one works. And then I'm going to check the 4 plus 10. Well, that's 14, and that is greater than the 7. And then I haven't checked out 7 plus 10. I'm going to compare that to 4. 7 plus 10 is 17. That is also greater than 4. Because the sum of any two sides is greater than the third side, the answer is yes. Those could be the sides of a triangle. Okay, let's try it again. This time we're going to use 2, 9, and 12. 2, 9, and 12. If it's easier for you, write the combinations down first. We're going to compare 2 plus 9 and compare it to 12. Then we're going to compare 2 plus 12, compare it to the 9, and 9 plus 12, and compare it to the 2. Might be easier to write the combinations first. You just have to decide the style you want to do it. Okay, 9 plus 2 is 11. Well, we already ran into a problem. That is not greater than 12. We can stop right there. So no, those cannot be sides of a triangle. Let me show you a little picture as to why that can't be. All right, 2 and 9. Here's my 12. I'm going to say that one's 12 units long. Now right beside it, I'm going to draw another one that is 11 units long. Let me just put it kind of above it so you can see. Oops, let's change that color. I want it to stand out a little bit, so let's make it blue. If I would start right here and make it 11 units long, right to there. Actually, that should be 9 units long. I said 11. That was the total, wasn't it? So 9 units is going to be a little bit shorter. Just make a comparison. Let's say that's 9. And then a third segment. Let's change it to purple. And that one's only going to be 2 units long. Now, I know they're not going to add up to be 12. They're going to be a little less than 12. So let me do this. If you look at those 2 short segments don't even meet. So they're not even as long as the 12. How on earth could I bend them up and make a triangle out of it? Is totally impossible. So again, you're looking for combinations to where when you add 2 sides together, it's bigger than the third side. Let's try one more. Let me write the combinations first. So we're going to add the 11.9 and the 5.8. And we're going to compare it to the 5.8. Then a second combination is 5.8 plus 5.8. And that needs to be 11.9. And technically there is a third combination. If we distinguish between those two 5.8s, there's the first one. We also have the 11.9 plus the second 5.8 to compare to the 5.8. That was interesting, wasn't it? All right, let's do the addition. 11.9 and 5.8. That is 17.7, which is greater than the 5.8. That works. 5.8 plus 5.8. Did you get 11.6? Oh, that is not greater than 11.9. This will never make a triangle. Our answer is no. Okay, on your Canvas page, there is a worksheet. It says Triangle Inequalities Theorem Worksheet. Ladies, if you will look at the instructions, it says girls, do the even-numbered problems. Boys, do the odd-numbered problems. You're going to have a whole list of these. There's quite a few in the list. Girls, I only want you to do the 2, 4, 6, 8, the even-numbered problems. Fellas, you're going to get exactly the same number. You're just going to do the odd-numbered ones, the 1, 3, 5, 7. We'll just kind of mix it up a little bit, and that way no one has to do all of them. After you practice with these for a while, where I give you the list of numbers, you're also going to run into something that looks like this last one. It says the lengths of two sides are given. Find the range of possible lengths for the third side. We're going to use the theorem again. We're going to use it in a similar way. But we're going to find out what the smallest and the largest lengths would be for that third side where we could still have a triangle. Okay. Since we don't have a number for that one, what I want you to do is let's just give it a variable name. I'm going to call it S. And we're going to write those three statements just like we did before. We're actually going to go ahead and put the greater than symbol in there. So first one, we know that 28 plus 23 has to be greater than S. There's our first statement. To have a triangle, this has to be true. We also know that 28 plus whatever that S would be has to be greater than 23. And the third combination for this to make a triangle, the 23 but plus that third side, the S, has to be greater than 28. Those three statements have to be true. We are going to simplify them and solve them for S, just like we would if there was an equals in there. On the first one, we can just add the two together, and we get 51 is greater than S. It's easier to read, I think, if you put the S on the left-hand side. So let's just spin it around and say S is less than 51. Remember, when you're dealing with inequalities, if the point of the inequality is pointing to the S, when you turn it around, that point still points to the S. On the second one, we're solving for S, so let's subtract 28 from both sides. S is greater than -5. I would hope so, because this is the length of a side length. They can't be negative. And on the last one, let's subtract 23 from both sides. S is greater than 5. Now we need to put all three of those together. It says find the range of possible lengths for the third side. We're looking for the largest it could be and the smallest it could be that makes all of these true. Well, the first statement says S is less than 51, and that's the only one that has a less than symbol in there. So that statement is telling us the largest number. It can't be 51, it's got to be less than 51. So we have the top part of our range. Now for the bottom part, we need to make sure that both of these two statements are true. So we need to think of numbers that are both greater than 5 and also greater than -5. Both statements have to be true. If a number is greater than -5 and it's also greater than 5, it means it has to be greater than 5. If you think about that, if it helps, think of it on a number line. Here's the number -5. Here's the number 5. Numbers greater than 5 are the numbers on a number line to the right of 5, or -5, I'm sorry. And if they're greater than 5, they're the numbers to the right of 5. If we're trying to figure out what numbers make both those statements true, you look at where the double lines are. That tells us that there are numbers greater than 5. When we put all of them together, smallest number is 5, largest number is 51. The sides of our triangle have to be between 5 and 51. Can't equal 5 and 51. Has to be ever so slightly bigger than 5, ever so slightly less than 51, but that would be our range. All right, that's a little different, so let's do another one, okay? Try one more time. This time our two side lengths are 6 and 11, a little bit smaller numbers. I'm going to call my third number, or my third side S again, and let's write the three statements. 6 plus 11 is greater than S. 6 plus S is greater than 11. And 11 plus S is greater than 6. All three combinations. Now we solve. 6 plus 11 is 17, is greater than S. Or if we switch it around, S is less than 17. The next one, if you subtract 6 from both sides of that inequality, we get S is greater than 5. And the next one, subtract 11 from both sides. So S is greater than -5. Okay, the only one that has a less than symbol is the first one. So it looks to me like if S is less than 17, that 17 is the biggest number S can be. The other two have greater than, so that we're going for the smallest value. We're looking for numbers that are both bigger than 5 and also bigger than -5. If that number line helped, here's the -5, here's the 5. Numbers bigger than -5 are to the right of -5. Numbers bigger than +5 are to the right, and the place where they are both true is this one, or numbers that are greater than 5. So 5 is bottom, S is between 5 and 17. You'll be able to try a few of those on your own on that worksheet. Again, ladies, you're doing the evens. Fellas, you're doing the odds. Use those two to kind of help guide you through it. Good luck. Ask me for help if you have questions, and we'll see you soon.